Hello everyone, welcome to day 29 of Leetcode May challenge. Today we have question number 318, maximum product of word length. In this question, they have given us the string array words and we have to return the maximum value of length of word 1 into length of word 2, where the two words do not share common letters, and if no two such word exist, we have to return 0. In example 1, word array is given to us and the two words out from this array which do not share the common letters and their product is maximum is this 2, and the length of ABCW is 4 and XTFN is also 4. So the product of these two is 16. That what is written as an output. In example 2, word array given to us is this, and the two words which does not share the common characters are AB and CD, and the length of AB is 2 and the length of CD is also 2. So after multiplying them, we'll get answer 4. In this word array, though we have the BCD which has the greater length than these two and ABCD, but as BCD and ABCD share the common characters, so we cannot include this in our answer. In example 3, the word array given to us have the same character, that is A, and as all the words have same character, so we cannot compare any word from the other word because they share the common characters, and that is not allowed because we need two words that do not share the common letters. So let's see how can we do this question. So method 1 of doing this question is, if this is the word array given to us and we have to find the maximum product of two words that does not share the common characters, then how can we find? So first approach is we can make a 2D array and then we can check if this AEC and AEC, like if they are having the common characters, we'll mark them cross. AEC and DAB, does they have the common characters? Yes, they have the common characters, that is A, so we will cross this also. AEC and BDF, do they have common characters? No, they don't have common characters. So the length of AEC is 3 and BDF is also 3. So we will multiply them and we will get the answer 9 over here. While in other case, AEC is compared with EC. They have the common characters EC. So this is not included. AEC and CC, this is not included. AEC and A have the common character A, so this is also not included. Then we will iterate to the next index. DAB and AEC have the common character A. We will not compare this with this. We will compare this DAB with DAB. So this is not allowed. Common characters DAB with BDF have the common character D, not allowed. DAB and EC doesn't have the common characters. Length of DAB is 3, length of EC is 2, so multiply their length, we get 6. DAB and CC doesn't have the common characters, so the length of CC is 2 and the length of DAB is also 3, so multiply them, 6. DAB and A have the common characters A, not included in the answer. Then we have BDF, not BDF and BDF have same characters, not included. BDF and EC don't have the common characters, so we multiply their length, we'll get 6. BDF and CC doesn't have common characters, multiply their length. BDF and A doesn't have common characters, multiply the length, so this is 1, this is 3, we'll get 3. And then we'll see further. EC and EC, no. EC and CC have the common characters, C not included. EC and A doesn't have the common characters, so multiply their length, that is 2. CC is not included. CC and A doesn't have the common characters, so the length is 2 and A is with A itself, that is not included. Now out of this we will find the maximum length which we got, 9, and that what we can return as an output. But using this method, the time complexity will be increased, because while we are creating this array and checking AEC present whether these DAB and AEC have the common characters or not, we are actually checking AEC with every other character. We are checking AEC with comparing it with DAB, and then with the next index, that is BDF, and then with the next index with EC. So we will loop it, we will have a nested loop. It will take n square time, and after that we have to, if they doesn't have the common characters, and then we have to find their length and have to multiply them. So that comparison will other take the n time, so total complexity will be n cube, and this solution if we will give, then we will get TLE. So what is the optimized way? How can we optimize this time complexity? So that approach is if we bit mask the number. What that mean is, if the word array given to us is this, so first we will convert all these words given in the word array to in the binary format, and then we will check, comparing two words with each other, we will check whether they have the common characters with them included in them or not. So let's see how can we do this. In order to convert any characters to its integer value, we will just minus the character with a. So a value is 97 and the character given to us is a, e, c, and we will find its binary value. So a, e, c is, character a is 97, so 97 minus 97 gives us 0. That means we have to initially, this is the binary array given to, like, of, as we have 26 alphabet, so we have created the array of 26 alphabet, and then we will check if this AEC have the number 0, that means going on that index we will put over there 1, like this particular element is present in this word array. So after we will go with e has 100 not 1, and when we will subtract it by 97 we will get 4. So at 4th index we have to change its value from 0 to 1, because default they all have the value 0. As e is present, so we will make it to 1. Similarly for c, it has the value 99, 99 minus 97 is 2, and this is 1, and every other element is 0. So after converting this in the binary, the value which we will get is 10101. So if we have to convert this is for AEC. Similarly we will do for DAB. For DAB, the value present at the index D, that is 100. So 100 minus 97 gives you 3. So over here we will have 1. A is at this index, so over here this is for string DAB, this binary bit, and it doesn't have B, it have B, sorry, so this is 1, it doesn't have C, and so C. So the after DAB, the binary which we got is, it is the 26, it has like all others will be 0, similarly for this also, but over here I am writing this. So one short string I am writing in order to explain you. So this is for DAB we got this string. This is 11001. And now when we perform the AND operation in this, if after performing the AND operation, if we got all result as 0, that means they don't share a common character, and then we will take out its length and multiply them. But if they share the common character, we will not get all 0. So let's see. 100, this is not 1, sorry, it is we are performing AND. So 100, 010, 100, 0, and this is 1. So that means they have the common characters. So this cannot be included in the answer. But what if we compare AEC with BDF, which somewhat have, which like for AEC our binary representation is this, but for BDF our binary representation will be 0, 1, 0, 1. This will be like A is not there, so 0, B, C, T. I'm doing this so that I can get the binary. Yeah. So E is not present, so 0, F is present, so 1. So that is how we are going to get it for BDF. And that what we are going to AND with the result of AEC, that is 1, 0, 1, 0, 1, and F is not present, so it is 0. This is for AEC, and this is for BD. This is for BDF. And when we will perform 1, the value which we will get is all zeros. So that means they don't share the common characters. So when we will multiply their length, we will get 9, and that is our one answer, and that is how we are going to compare with everyone, and we will give the maximum, and we will return the maximum product that we get. So now let's code it up. So as we know, this is more simple when we are using the bit operation, bit mask, or we are doing the left shift, performing the left shift. So first thing is, we will have this base check, that is if words is null or length is equals to 0, we will simply return 0. Else first we will perform what? We will length is equals to words dot length, and we will create the array which will have the bit value of the number, and that will be of same length as of the word. And then we will loop it. I is less than the length I plus plus for integer j is equals to 0, and j will have the that particular word length. J will go to till that particular word length, and j plus plus. And now in the bit value, we will perform the left shift operation dot character at j in order to change it to the integer, and after this we will have a loop to get the maximum value, and that we have to return. So how we are going to loop it is from for we will compare this for the maximum length I plus plus, and the other loop will go from I plus 1 till the length. If when we are performing, we will first ask, we need the bit value of I, and when we end the bit value of I with bit value present at j, and if they give us 0, then we will find their product. So we will have here product, and that will have words of I dot length, because it is in words array, so we will find the length from there. And then we will just have this check if our maximum is less than the product which we got now. So we just update our maximum, and we will just return the maximum. So let's run this code. Okay, what is wrong? Bit value of I, left shift operation to the words of I dot character at. Okay, this integer is missing. Yeah. Bit value of I, and we are ending it with the bit value of j. Okay, this is the check. If this condition is holding true, then we will find the product. We are getting, let's submit it. So the time complexity of using this approach is O of n square.